Okay, Unit 5, it's all about fractions. A toughie, but we'll go through slowly and it should be okay. Learning goal number 1 then, you're going to want to write down, I can add and subtract fractions with a common denominator. And don't worry if you don't know what that means quite yet. Our first part will be all about vocab.
Sure will.
So we have some nice visuals here to help you out as well. Our first vocab word that you are going to want to write down, it is a little bit of writing, but I think it will help you in the long run, is a numerator. The numerator is the number on the top of the fraction. This is, most of you probably already knew that part, but this is the part that's really important. So I know it's an extra sentence, but it's worth it. The numerator tells you how much of a whole that you have. So for instance, with the visual there, there's 3/4. It's saying that we have 3 out of the 4 pieces. So that's important to know.
Yeah, so this is the numerator up here.
Yes. Denominator then is, of course, the number on the bottom. I always think down for denominator to help me remember the two. And so the number on the bottom of a fraction is the denominator. Once again, we have one more sentence for you, though, just to help explain that a little bit more. The denominator actually tells you how many pieces are in the whole then. So you'll see that picture over there. There's 4 actual pieces, but 3 out of the 4 are shaded in.
Yep. And that shouldn't be anything new, really.
No.
I mean, you've seen these before, but it's good to know exactly what the numerator and denominator are.
Exactly. Now this one might be new. A unit fraction, we're going to refer to that sometimes quite a bit, so you should make sure that you know that a unit fraction is really just another name for when there's a the numerator is 1. That's all that means.
So like 1/8, 1/12, 1/16, 1/100th, those are all considered unit fractions.
Exactly.
Okay, so looking at some examples, we have here the addition sentence 1/4 plus 2/4. So we're going to show you a little bit of a visual here. So we've got our fraction bars, we've got our 1 whole, and if I took this fraction bar and laid it on top of this, it would land exactly on top. So you've probably seen something like this, but we're going to use that to help you just see the visual of how to add these together. So first we have 1/4, so I have that 1/4 circled in, plus 2/4, so I'm going to circle in, since we're adding, it's going to go right next to it, equals, and if you look at that, well now we have 1, 2, 3. So we have 3/4. So there's sort of a rule, and this is something you're going to write down. You can put even a little star or highlight it if you want to. If the denominator is the same, then you can add the numerators. You'll just leave the denominator alone. Okay? Notice this didn't become 3/8.
Right. That's a common mistake.
Because, I mean, if you looked at that, if you said this was 3/8, and you look down here, 1, 2, 3, 3/8 is much smaller.
Right.
So when the denominators are the same, you add the numerators, leave the denominators all alone. Okay?
So then we just want to go through one more example just to show you, and then you'll probably do a couple. But here, we're going to look at 8ths. And so, well, thanks. Once again, we're going to look here and circle. Here's my 2/8, and then we're just adding on 5/8. So here they are all circled, and you can count them out, or you can just look up here at the numerators and realize that we have 7/8 then. In 1, 2, 3, 4, 5, 6, 7. Sure enough, 7/8.
Nope.
Not 16ths.
No. Alright, so this one I want you to pause it and try it. So actually write down the equation and then write your answer. And then we will give you the answer to this one, but try it first. Okay, so if we look at these, we're talking tenths now. So our first one is 4/10. So I have that circled so you can see that for you visual people. Plus 3/10 equals 7/10. So hopefully you all got that one. And now it's your turn to try a couple. So in your journal, if you could write number 1 and number 2, and then write these equations down here, 1/6 plus 3/6, and then 7/12 plus 3/12. And then you need to also solve them. So we'll be checking those tomorrow when you come in. And then we will move on to subtraction, I believe.
Yeah, wow.
Yeah.
Alrighty, here we go. So, looking here, we're going to look at 2/4, and we just want you to see visually too what that's going to look like. So we'll just circle these 2/4. Now, the big idea here though is we're, once again, subtracting, we're taking away. Right. We know you know that, but sometimes with fractions we just want to make sure. So we're looking here, and instead of adding on another fraction like we did before, we are going to take that away, cross it off. So visually it's really easy to see now that you only have 1/4 left. So that should be your answer then.
And hopefully you notice, if you want to keep clicking.
Oh yes.
Similar. No, we're good.
Yeah. So take a moment just to jot this down though again, just with subtracting, or just like adding. If the denominator is the same, all you have to do is subtract these numerators, and you get to keep the denominator the same. Nice and easy.
Yep, when the denominators are the same, it's pretty simple to add and subtract. The only thing that'll really mess you up is if you try and do something with the denominators, which you don't want to do. It gets a little trickier when the denominators are different, which is learning goal 2.
So enjoy this one.
Enjoy it while it lasts. All right, we're going to do one more example, and then we'll let you try one. So our next one is 5/8 minus 2/8. So I've got my 5/8, and since I am taking 2/8 away, I'm going to cross them out, which leaves me with, if I look, 1, 2, 3. So I have 3/8 left.
Oh yes. So you're going to pause and try this one. So once again, that means actually writing this out. It'll be a lot easier to find it when you're referring to it later in your group. So we have 4/10 and take away or subtract by 3/10. So pause for a moment and solve that. All right, then looking here visually, we can see we have 4/10 here. And once again, we're going to take away those 3/10. And you should have gotten 1/10. Now, please make sure to write down number 3 and 4 in your journal. We're just going to tack on from the other two. And very similar, you're going to take a moment to think about what the rules are for subtracting fractions with common denominators. And you're going to write these down: 3/6 minus 1/6. Add your answer there. And then with number 4 here as well, label please 7/12 minus 3/12, and should have a lovely little answer there as well.
The next thing we're going to be moving on to is talking about how a fraction looks if it is a whole fraction, like you have all of the pieces. So if you think about it like this pizza here, let's say you ordered a whole pizza, and when it got there, it was cut into 6 pieces. No one ate any on the way. It's all there. So how many pieces do you have? What fraction of that whole pizza do you have? So if you remember back to our definition of the numerator denominator, numerator is how many pieces you have, or how many you're talking about. So we have 6 pieces right there. They're all there. Out of how many total? Well, 6 total. So the fraction representing our whole is 6/6. So any number, as long as you have, if you're talking a fraction, if the numerator and the denominator are the same, it's going to equal 1 whole, no matter what. If you had a pizza split into 100 pieces, that would be a really big pizza, or really small pieces.
Yeah.
If you had 100 of the 100 pieces, you have a whole pizza still. Okay? Your one whole pizza might be bigger than another whole pizza, but that's what these equal out to be. That's what we want you to get, is that if you have the numerator and denominator are the same, that they equal 1 whole.
So this one, just you're going to take what you learned about the pizza, and now you're going to think about a box of pencils. And this one you do want to write down in your math journal. So just think about this. You maybe it's the beginning of the school year, and you have a new box of pencils. If they're,
I could use some more of these.
I know.
We have no pencils.
Maybe the new part of the second part of the year, and we get a bunch of new supplies. Wouldn't that be lovely?
Great.
So someone comes to school with a new box of pencils. If there are 10 pencils in a box and you still have that whole box, what fraction of pencils do you have? So just pause, please, jot it down, see if you can apply what you learned from the pizza.
And your answer should be a fraction.
Oh, yes.
Right, well, you said it, but I want to,
Okay.
I mean, it would be easy to say 1 box or 10 pencils, but what fraction of pencils do you have? That's kind of the key there. So you should be writing a fraction down.
So let's see if you came up with the correct answer. It should be 10 over 10, or 10 tenths. So hopefully that's what you have. Oh, is that me? Okay. So now all you have to do is apply that once again. You're going to jot down in your math journal number 5, and this time what you're going to see is you have to just solve for n. So you want to look at the denominator and think about, okay, if I need to make 1 whole, what does my numerator need to be there? Same with number 6, but we just flip-flopped it for you. You have 250 as the numerator, and now you have to solve for d. What would your denominator be if you still want to make that 1 whole? So make sure to add that to your journal.
And I think these are the last ones that we're going to do, this little section. So again, we're looking back at our fraction bars, and we're going to use now what we talked about how to make it equal to a whole with these. So let's say you're missing one of these fractions in your addition sentence, but you know the answer. You can solve addition problems like this. 2 plus x equals 6. Well, you know it's 4, right? 2 plus 4 gives you 6. So how would we do that if it's a fraction? So the first step for this is to actually change your 1. You want to turn this into a fraction, but not any fraction. I mean, it still has to equal 1. So if we're talking eighths, how many eighths equal 1 whole? Mrs. Van Dam, do you know?
I think I know. I think it should be 8 eighths.
She is so smart. So we have 2 eighths plus something gives you 8 eighths now. So you see here, 1 and 8 eighths are identical. They're not identical, equivalent. They're equivalent. So 1 and 8 eighths are the same thing. So we didn't change the equation at all. All we did was change this a little bit so it was easier to work with. So 2 eighths plus what equals 8 eighths? Or we could even think of m as eighths. So 2 eighths plus how many eighths equal 8 eighths? So what do you think? 2 plus 6, right? 2 plus 6 gives you 8. So 2 eighths plus 6 eighths equals 8 eighths. So that's one little example. Yeah. And this is, I mean, it's a little more difficult, but still, if you remember to change this one into a fraction, you can definitely handle this.
And I was just thinking when we're talking about 8 eighths, looking on our visual here, you know, we have 8 eighths, and once again, it's equal to our 1 whole right there. So that's just another way to prove that this makes sense. All right. So is this one they're pausing?
Yep.
Thank you. Yep. So in a moment, you are going to pause and try to solve this one. So take a moment to do that, and then we'll walk you through it, though, to make sure you're on the right track.
And if you forgot the steps, just rewind it and see how we solved the last one, and then just apply that to what you have here.
Definitely. So thinking about the steps here, we have 3/12 plus m equals 1. So we know that this 1 whole, by now, hopefully you're thinking, well, I want to change this into a fraction so it's just easier to work with. So 1 whole should be changed to what kind of fraction do you think to make this
keep
work?
it the same denominator, so probably a 12ths, right?
Yes. So this is the first step. Now we have 3/12 plus m equals 12/12. Now we just have to solve for m, and it should look a lot easier now. Now that you're getting more comfortable with adding fractions. So you should have ended up with 9/12 as m here. 3/12 plus 9/12 should equal 12/12. This is it, we promise. I know there's a lot of writing on this one, but you are going to write down number 7 in your math journal, and you are going to solve this all on your own, and then come back and be ready to share with your group. And then same with number 8, and hopefully we'll see a lot of correct answers.
Hope so.